Hello. Now, in one previous video, we demonstrated, I listed the different topics that you guys are supposed to cover in term 1, the first week, the second week, the third week, up to the last week of term 1. And I also broke it down into which topic should be covered in which week, which topic should follow the first topic, which topic should follow the third topic, that way. So I basically introduced the whole thing that you guys require to know for the first term work. Now in this video, we continue with what we discussed in the first video, which is basically the definitions of exponents. That was the first topic, exponents and surds. Now in the first lesson, we discussed the different laws of exponents. We also looked at the definition of an exponent, where we said an exponent of any number or a variable represents the number of times that number or the variable is multiplying itself. We did that while I was sharing some screen with you, and that is also what I'm going to be doing for now. I will be sharing with you a screen, and from the screen that I am going to share, we will be looking at how do we then apply the different rules of exponents. You see? So now after understanding what it means by exponent, you now want to find out, well, how else do we use it apart from defining it out? So as indicated earlier, exponent of any number represents the number of times that number multiplies itself. These on the screen are the rules of exponents. The first one states that when you multiply two same numbers with the different exponents, you can simplify that by adding the exponents. The second one is about dividing two same numbers with the different exponents, which you can simplify by subtracting the exponents. And in the third one, we see that if you have an exponent outside an item or outside some items inside the bracket, you can simplify this, okay? You can simplify this by splitting the exponents into the individual as the exponents of the individual quantity inside the bracket. This one only works when the items inside the bracket are multiplying each other. Like you can see here, A times B. It does not work that way if you have A plus B or A minus B. Also, when you are dividing with an exponent outside, you can bring the exponents inside as exponents of the individual quantities being divided. And lastly, we also saw that if you have an exponent outside an item, a single item inside the bracket, with the item inside the bracket having an exponent of itself, then you can simplify that by multiplying the two exponents. Now, in the cases listed here, A must be greater than 0. The numbers you're multiplying must be greater than 0. B, also the number participating in the multiplication or division must be greater than 0. The exponents M and N are integers. Now, we want to move on and break down those rules. So the first rule, we saw that, well, when you multiply two numbers that are the same, even if they have different exponents, you can simplify it by adding the exponents. Now that then means if you have 2 times 2, okay, if you have 2 times 2, you can simplify this as 2, then with exponent of what? With exponent of the separate exponents being added. That is, you now have to add this 3 to this 2, so that you have 3 plus what? Plus 2. This gives us what? 2 with exponent of 5. Rather, yeah, 2 with exponents of 5. And that becomes the solution, okay? 2 with exponents of 5. Now, notice that there are times when you will have to deal with a number which is not like the same, but you can reduce them to the same quantity. See that? Now we will look at that one in one other example, but this is what we are dealing with. Now in the second example, you notice that we have to multiply W with another W. The exponent of the first W is 1, the exponent of the second W is 5. So how do you simplify that? Well, we simplify that by adding the exponent, the separate exponents, okay? So that means we'll be adding 1 to 5 to give us what? To give us the value of W with exponent of 6. W with exponent of 6. That would be the what? The value. Now, for this one, well, it's still the same. The fact here is these two numbers, 4 and 4, are multiplying each other. So that means to simplify that, we will still do what? We will still add the separate exponents. So that we have minus 3, this time added to what? To 2. And what will that be? Well, this will be 4 with the exponent of what? 4 with the exponent of negative 1. That is what we get when we do what? When we add negative 3 to positive 2. Yes, that is it. Now, the other thing I wanted to include here is that supposing you have this type of number, I'm just going to include it as one of the examples right here. Oh, sorry, this one is not accepting. So supposing you have, okay, supposing you have 2 with exponent of 3. Just to get this, 2 with exponent of 3 is being used to multiply some other quantity. Let's say this time 16. How are you going to simplify this? Well, we will be having 2 with exponent of 3 before we can apply, okay? Before we can apply this rule, the product rule. Notice that we supply, or rather we apply this rule when the numbers are the same. Here it's A and here it's A. What is not the same, or what may not be the same in this case, will be the exponent. So we have to express 16 as exponent of 2. And how do we do that? Well, we'll be having 2 exponent 3 times 2 exponent what? Times 2 exponent 4. Like that. So that way, because 2 exponent 4 is 16, that way we'll get what? We'll get 2 with exponent of what? 2 with exponent of 3 added to 4. That is 3 added to 4. So that we get 2 exponent 7. That's how you would simplify that. And a lot of the questions will require you to apply this type of knowledge of first simplifying a much more complex quantity, okay, into a fairly reduced quantity, looking at the numbers multiplying themselves, the bases being the same. That is what we have. Now for the second rule is about what? It's about dividing things. So we call it what? The quotient rule. The quotient rule states that if you are dividing two bases that are the same, if they have different exponents, okay? Even if they have the same exponent, you simplify the two divisions, or the two numbers being divided as what? As the number with the exponents being subtracted. That means 5 divided by 7, rather 5 exponent 7 divided by 5 exponent 3 can then be simplified as 5 exponent what? 7 minus 3. And so this will give us 5 exponent 7 minus 3. So this will give us the value of 5 exponent what? Exponent 4. That's what we get when we take away 3 from what? From 7. Now in the next question, we have this. Well, now notice that we have a combination of stuffs here. So x and x are the same. Yes, that's some easy deal. But now we have 6 and 2. What do we do with this? Well, we just go with the traditional way, the conventional way of dividing 6 by 2, which gives us what? 3. Then now for the x, we'll be writing x with exponent what? X with exponent 2 minus 5. So this will give us exponent 2 minus 5, because the bottom line is the two exponents must be subtracted if we are dividing the bases. And so we can then simplify this to what? To 3 times x exponent what? Times x exponent negative 3. That is what we get when we take away what? When we take away 5 from 2, we get negative 3. Now in the next question, well, what we have here is 4 exponent 5 divided by 4 exponent 5. We can simplify this into what? We can simplify this as 4 exponent what? Exponent 5 minus 5. Okay? That is what we have. And so this will give us 4 exponent what? 4 exponent 0. That is what we get when we take away 5 from 5. Notice that 4 exponent 0 gives what? Gives 1. So that's how you would simplify the what? The quotient rule. Now for the product rule, we have this. The product rule of exponent allows us to do what? I mean, if the two numbers are multiplying each other, then the product or the exponent outside can be distributed as the exponent of the individual terms inside. Notice that this only works when the sign between these two is what? Is multiplication. That is A times B. Or when the sign between two is what? Is division, as we will be looking at it in the next question. Notice it does not work if you have a minus there or a plus, rather, or a plus. It doesn't work if you have a minus or a plus. So because of this, we can have these two. Now, because of that, we can bring this 4 as exponent of what? 3 and 4 as exponent of 5. So basically, we'll still be having 3 times 5 now with the exponents distributed. So we have got to be having 3 and 5. That is 3 times 5 with the 3 having exponent of what? 3 having exponent of 4. Like that. And 5 in this case will also be having exponent of what? Will be having exponent of 4. So the question is, what else do we have from this? Well, interestingly, we now have to simplify this using what? Using a calculator. So I'm going to be using the calculator, which I have right with me here. So that I will be writing 3 exponent 4. Okay. So I'll be starting with 3 exponent 4. In case you do have a calculator with you, you can also check this out. We want to find 3 exponent 4. 3 exponent 4. That gives 81. Okay. Then the next thing we want to deal with is 5 exponent 4. So the next thing is 5 exponent 4. So 5 exponent 4 gives what? 625. So now when we multiply this, okay, when we multiply these two, that is 625 times 81, what we get is a quantity which is what? 50,000 and what? 625. That's what we get. Now, coming on to the second question, well, it's a similar approach. We'll still be having 2 and 7, that is 2 times 7. Okay, we'll still be having 2 times 7. Now, with the 6 distributed as exponent of 2 and as exponent of 7. So that way we'll be having what? 2 exponent of 6. Then 7 exponent what? 7 exponent 6. Like that. So in the next step, we find the what? We find the value that each of them will be giving. So that means we are going to find the value of 2 exponent 6, that is 2 exponent 6, giving us 64. Now this 64 will be used to multiply what? What we get when we raise 7 to 6, that is 7 exponent 6. 7 exponent 6. 7 exponent 6 is giving me, well, 100,017, 117, then 600 what? 49. So when we multiply these two, that is, when we multiply 64 times 117,649, we get, well, we get 7,529,000 then 536. That's what we get. Now, how about this? Well, just reduce this a little bit so that it can fit on one line. All right, there we go. So how about this? Now, notice that this one will also still give us the same value of 6 and 4, okay? With what? With the exponent distributed. So we'll be having the exponent distributed, the exponent of 0 distributed on 6, okay? The exponent of 0 will be distributed on 6, that is 6 exponent 0. Then also the exponent of 0 will be distributed on 4, so that we have 4 exponent what? 4 exponent 0, that way. So now from that, we'll be having, well, notice that 6 exponent 0 is 1. That we now have to multiply with what? 4 exponent 0, which is also 1, and that gives us a final value of 1. Now, a similar approach is also used when we are dealing with what? The quotient rule. For example, the quotient rule in this case for exponent states that when you have two quantities being divided inside the bracket with external what? Exponent outside the bracket, this exponent can be distributed to the individual terms so that each of the terms will be having the what? That same external exponent as indicated here. And so that means for this question, 3 divided by 4, we will be having what? We'll then be having, well, 3 divided by 4 first, like that. Then 3 will be raised to exponent 4. Then also, sorry, this is 5. This is 5, which also has got to be raised to exponent of what? Has got to be raised to exponent of 4. Like that. So then in the next step, we get the simplified values. That is, we will now do what? We will now raise 3 to 4. So that we get 81, okay? This 81 has got to be divided by what we get when we raise 5 to 4. That is 5 exponent 4, okay? 5 exponent 4 will give us a value of 625, like that. So now we can divide these two quantities. That is 81 divided by 625. Well, that will give us 0.1296. Well, we could write that 0.1296, or you could stop, leave it at this. There isn't any crime with that. Now the next thing here is this second question. Well, we still have one that we have to divide by 4. One that we have to divide by what? By 4. Now notice that this one has got to be raised to exponent of 3, okay? 1 is raised to 3. In other words, 1 has got the exponent of 3, and also 4 has got the exponent of what? Of 3. Like that. So this way, what we will then be having is going to be, well, 1 exponent 3 is still 1. That is 1 times 1 times what? That is 1 times 1 times 1. 1 multiplying itself 3 times, okay? So we then have to divide this by what? By 4 raised to the exponent of 3, which we can get it right away here. So 4 exponent 3 giving 64. Well, that is our answer. Or we could go ahead and do what? And find what? The simplified version of that. That is 1 divided by 64. This gives 1,015625. That's what we get. How about when we are dealing with stuffs like this? Well, the whole thing still stays the same. How? Well, in the sense that this quantity here, x with exponent 5, must still appear where? Must still appear here. So we'll be having x exponent what? Exponent 5, x exponent 5, then y exponent what? Y exponent 2. So y exponent 2 like that. So now there is this extra 3 outside. Now what we do with this extra 3 outside is simple. We just multiply it. So we'll be multiplying this by what? By 3. And also we'll be multiplying the what? The lower exponent of y with what? With 3. So that we get what? A much more simplified version. So in this case, the next step will then be, well, will then be x raised to what? X raised to 15. That is what we get when we multiply 5 by 3. X raised to 15. Then the denominator will be y raised to what? Y raised to 6. That is the exponent of y will this time be what? Will be 6. So yes, that's how we deal with this type of thing. Now the next thing we want to include before we, well, the next thing here is this, the power rule for exponents, which allows us to multiply the exponents as we just did it in the what? In the previous example. So right away here, we'll be having a with exponent of what? Exponent of 5. So we'll be having a with exponent of 5. This 5 is multiplied by 2, like that. So that we get what? So that we get a with exponent of 10. That's what we get when we multiply 2 by 5. Now for the second one, we will have something similar. That is, we'll be having 2 with exponent 2. 2 with exponent 2. And now this exponent of 2 is supposed to be used to multiply the outside exponent, which is what? Which is -3. Well, what do we get in this case? What we'll get in this case is going to be 2 with exponent -6. That is what we get when we multiply 2 by -3. Then for the third one, well, still similar. We'll be having x with what? X with exponent 3. So this will be x with exponent of 3, which will multiply with what? With 2. Yes, so that we will get the value of x with exponent of 6. Yes, now the other one, well, it's what we have here. Any number or any letter raised to 1 is 1. That's pretty obvious. We're not going to have an example on that. We would rather look at this, the 0 exponent rule, which means any number raised to 0 is 1, which already appeared in one of the example we did right up there. Now, this then means y raised to the power 0 is going to be 1. Also, this one here. Notice that, well, by the rule we saw previously, we would have to do what? We would have to distribute this 0 onto what? Onto 6, and this 0 onto this 1, which will eventually give 1. So you can see here the whole thing is still 1, or if you like it the slow way, well, you could say 6 with exponent what? 6 with exponent of 0. This time, the 6 is used to multiply x squared, okay? Like that, x is being squared. All right, then also the square has got to be what? Has got to be multiplied with the 0. So that will give us 6 exponent 0 as 1. Okay, that's what we are going to get for 6 exponent 0. Now notice that this 6 exponent 0, which is 1, must be multiplied with this other quantity, which is also 1. So finally, what do we get? We get 1. So here is another example. How about this? Now notice that in this case, the 0 is only the exponent for b, but not for these other quantities. In other words, we are going to be having 7a exponent what? 7a exponent 3. Just like this, 7a exponent 3, which we have to multiply with b exponent 0, which is 1. So from here, you can see that we can simplify this as what? 7a exponent 3. 7a exponent what? Exponent 3. And yes, this brings us to the conclusion of the basic rules, okay? The basic rules of exponents. The thing now that we want to move into, which will appear in the next example or possibly in the next video, is how do we handle the case of fractional exponents? That will be in our next video. For this video, this is where we stop.